Hi, welcome back to the second part of the water topic. For this video, we'll be mainly focusing on evaporation, what causes evaporation, and the four factors that affect the rate of evaporation. But before I talk about evaporation, I'll also be going through the temperature changes in the graph and what does it mean. Because as you progresses to P5 and P6, graph question will become more and more common. Okay, so you need to know how to read the graph of when water gains heat lah. Okay, so this is the first slide, the one that I'm talking about. Okay, so how do we read this? Basically, I mean, on the surface level, what you can understand is that from this is the temperature. I already tell you. This is the time. So basically, generally, as an overview, what you can conclude is that as time passes, the temperature of the water increases. Okay, I'm just gonna write temperature increase. Okay, because as you can see, it's going upwards. Okay, so basically, on the surface level, what can you see is that the temperature didn't change here. The temperature rises, the temperature stay the same, the temperature rises, and then the temperature stay the same. Okay, so I mean, most students will be able to see this. So what we're going to talk about today is to see more in depth what are the things that is beyond the surface level that you can understand from this graph. Okay, I'll have to first erase it. Okay, now, so basically at the 0 minute mark, okay, the temperature is 0. At the 5 minute mark, it's also 0. Usually, the question will tell you that this is an ice cube that was removed from the refrigerator. Okay, if you pay attention to the previous video, you understand that when you just take out from the fridge, it is still an ice cube. Okay, and then you start melting. Okay, then this is when it fully melts. It becomes puddle water, so it has fully melted already. That's why the temperature rises. And then we have also discussed in the previous video why is it that the temperature did not increase when the water is melting. Why is the temperature same? Why is it still 0 degrees here? That's because the heat energy that is needed to allow the ice to melt is being used to melt the ice. It is not used to increase the temperature of the water. So that's why the temperature did not increase. So when it's fully melted, okay, the temperature will then rise. Okay, so what you can conclude is this. Here to here, the 0 to 5 minute mark is mostly solid state in ice. Of course, it is partially melted, so it also includes a bit of liquid as well. Okay, now then obviously the temperature rises. Okay, and then after that it stopped here. Why did it stop? Okay, reason is because it has reached the temperature same with the environment. So what is the temperature of the environment? So same as environment, right? The temperature. So from the graph you can deduce that the environment, the surrounding temperature is 30 degrees Celsius. Okay, so that is beyond the surface what you can understand from the graph. The second thing you can understand is why is it that the temperature stopped at 30 degrees Celsius of the water? Why did it not increase? This tells you that if the water or the temperature did not increase beyond the room temperature, that means the water is not heated. That means it is not heated over a flame. Because if it was to be boiled, the water would have continued rising. Because this is not the boiling point, or I would say not the max temperature of water. Max temperature of water is called boiling point, which is 100 degrees Celsius. Okay, so from here what I can understand is that this ice cube is taken out from the fridge it is left somewhere. They did not apply flame to it, did not apply any fire over it. That's why although the ice gained heat from the environment, it did not rise beyond the room temperature. That's why it stopped here. Okay, so that's what you understand so far. Now let's continue with the diagram. Then suddenly at this point you realize that the temperature starts rising again. So why is it that the temperature will rise above room temperature? There's two possibilities. The surrounding temperature has increased already, but we can reject this gas. Why is it that it is not possible? Because the water rises up to 100 degrees Celsius. It's impossible, highly unlikely that the environment has the surrounding is 100 degrees Celsius. Okay, so the second most possible reasoning is that it is being heated. That means probably they boil the water. That's why the water temperature starts rising. Okay, so if they ask you during exam, at what point was the water heated or boiled? It was being heated at the 15-minute mark. Okay, now, so the temperature rise up to 100 degrees Celsius and then it didn't grow anymore. It stays the same, stays constant. During exam, sometimes they also ask you, when did the fire, or when did the stove, or when was the water removed from the stove? So the answer is not 25 minutes. It is not. Why? Because logically, if you think about it, if you boil water, you remove the water from the stove or you off the fire at the stove, the water will start cooling down, right? Okay, then that's when after that you can drink the water because the temperature will drop. So why is it that, what is happening here? Why the temperature stays the same? Because at this point of time, it is still being heated. It is still getting heat from the stove. That means the fire is not off. Then comes the second question. If it is still at the stove, why did the temperature not rise any further? Reason very simple. This is what you call the boiling point. And what is the meaning of boiling point? Last week we went through. Boiling point is the maximum temperature. Okay, that's why the water did not rise above that, because water cannot rise above its boiling point, above its maximum temperature, just like why it cannot drop below the freezing point, which is 0 degrees Celsius. Okay, so as long as the temperature don't drop, you can assume that it is being heated over a flame, over a stove, over fire. Now, if, let's say for example, the temperature starts dropping, okay, at perhaps the 35-minute mark, which is not shown on the graph, then you can conclude that yes, okay, it is being removed from the stove or the fire has been switched off. Okay, so that's what you understand from the graph. Now, if you did not put the boiled water back into the fridge, you will conclude that it will drop back to room temperature at about 25 degrees, at about 30 degrees Celsius. If after some time you decided that you want to place it in the fridge, of course you drop to 0 degrees Celsius and then freeze to become ice. So that's what you can understand. Okay, so if you can understand so in-depth, such in-depth information about the graph, then it will definitely help you in your exam. A quick recap on evaporation before we talk about the factors that affect evaporation. Okay, it's pretty much the same as the previous video. So evaporation is when water turns to water vapor. Okay, and always remember, evaporation takes place at any temperature. It does not have to take place at 100 degrees Celsius. A lot of students think that it does take place at 100 degrees Celsius, which is totally wrong. As long as water gain heat, it will evaporate. It doesn't have to be at 100 degrees Celsius. Okay, and evaporation takes place on the surface of the water. Okay, now evaporation rate will differ based on 4 factors that we'll discuss later. So how fast water evaporates depends. That's why sometimes you realize if you spill water, maybe in your classroom, you realize after a few periods, a few hours, the water is still in your classroom. It didn't evaporate. But if you accidentally maybe spill it in a courtyard or parade square, you realize that the water disappears very quickly because they evaporate very quickly. So why is it that water will evaporate at different rate? That's because of the factors that affect them, and there are 4 factors which we will discuss. Okay, now, so these are the 4 factors, namely the temperature, the exposed surface area, the humidity, and the wind. Okay, you have to memorize these 4 factors. We'll discuss in depth from the next slide onwards. Let's talk about the first factor that affects the rate of evaporation, which is temperature. It is also one of the most commonly tested factors. Okay, but before I can tell you how temperature affects the rate, how fast water evaporates, you need to understand how water evaporates. Now, inside water, actually we should know lah. I don't know if you all know this because it's actually taught in primary school, but basically solid, liquid and gas matters, 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 they are made from particles, and inside water there's also particles. So when they gain they gain energy from heat, okay, the particles will be converted into, the liquid will be converted into gas. Okay, so it's because of the energy they gain from the heat, that's why they change. So when the temperature is higher, it will actually suggest that there's actually more heat in the surrounding. So the water gains heat from the surrounding and then they evaporate. So when you have more heat, there will be a faster evaporation. Okay, so in summary, higher temperature means faster evaporation, and when the temperature is lower, the evaporation will be slower as well. Okay, now before I talk about what is the best time to sun your clothes, let's go back to spilling water again. Okay, you spill water on a sunny day, okay, when the water is directly under the sun on a very hot day, okay, you expect the water to evaporate very quickly, to disappear very quickly, because they evaporate and turn into water vapor already. Likewise, if let's say for example you're in a place that's not hot, in fact it can be a place that's very cooling, if you spill the water, you realize the water will take a very long time to evaporate. So from this we can see that when the temperature is higher, the evaporation is faster. Okay, so if you help out your parents with household chores, like for example sunning the clothes, you should know that the best time to sun your clothes is in the day, especially when the sun is hot at about 12 p.m. okay, 12 to 1 p.m. okay, that's because when the sun is when earth is nearest to the sun and the temperature on earth is the hottest, okay, the temperature is highest, so there will be more heat, so the clothes in your water will evaporate faster, so your clothes will dry faster. That's why right in the afternoon, that is the best time to sun your clothes as compared to at night when there's no sun and the temperature is substantially lower. Okay, now the second factor is exposed surface area. So as you know, evaporation only takes place on the surface of the water, okay, and water gain heat from the surface that's exposed to the environment, because the environment has heat which they gain heat from. So if you have two containers, right, let's say they are both the same amount of water, let's take it as 500 milliliter each, okay, but you realize that the surface area here is lesser, the surface area here is more, because so the evaporation here will be more, evaporation here will be lesser, therefore this one will evaporate faster. Okay, and that's how exposed surface area affects the rate of evaporation. So when the surface area is bigger, you have more surface to gain heat, and therefore the evaporation is faster. Okay, so just very simple. So big surface area, fast evaporation, very logical. Bigger, faster, simple as that. Okay, so again, if you have help out with your household chores before, okay, you realize that when we sun our clothes, we sun it in a way, okay, I mean you can do it in a lot of ways. You can just take it out from the washing machine in one huge lump and just leave it there, but why don't we do that? Okay, why don't we just leave our pile of clothes there? Why must we hang it? That is because when you hang it, okay, the surface area is bigger. Say for example, Okay, you have these clothes, as compared if to you have a lump of clothes. I don't know how to draw a lump of clothes, but maybe I'll just draw a folded one. So after a clothes is folded, it becomes so small. This is the surface area. This is the surface area. Which one is bigger? Of course, the one that is wide open is bigger. Okay. Then of course, sometimes during exam it may be a bit tricky. How about comparing with hanging on a chair? Hanging on a chair is also wide open, but however, if you hang it on uh, your service yard, okay, or hang on a hanger, you have both sides of the shirt that's exposed. But if you lay it on a chair, only one side is exposed. So obviously the one that's being hanged on a hanger, it has more surface area, and therefore the evaporation will be faster as compared to the one that's left on the chair that only has one side of exposed surface area. Okay, so to summarize, the more surface area, the bigger surface area, the better, the faster the evaporation. Okay, now then let's look at this. Okay, so sometimes during exam, again, they'll be very tricky. They give you a container that is a weird shape. Now you realize that at first the surface area is quite big. Let's say after sometimes the water is evaporated, right? It becomes like that, right? The surface area from big become small. Okay, so at first, since it has big surface area, the evaporation is fast. Later, when it has small surface area, the evaporation will become slower. Or on the contrary, on the right side, this one is small surface area, small exposed surface area. Then after sometimes when it evaporates, it has bigger exposed surface area. So at first it will be slower. Then after some time, because of a bigger surface area, the evaporation will be faster. Now we are left with two factors, wind and humidity. Before I can talk about how wind affect, you need to know how humidity affect. Before I can talk about how humidity affect, we need to clear up what is the actual meaning of humidity, because a lot of people has a wrong understanding of the word humidity, because the word is used very loosely. For example, if you realize you sweat a lot, you feel very uncomfortable, sticky, we always say, wow, what a humid day. But it doesn't mean humidity is how hot uh, the surrounding is. Okay, humidity actually has to do with the amount of water in the air. To be more exact, the amount of water vapor in the air. Okay, so let's look at this. Okay, we can't see water vapor. Okay, but if we can see water vapor, okay, if there are very little water vapor in the surrounding, we call it low humidity. Whereas if there's a lot of water vapor in our surrounding, it's called high humidity. Simple as that. Okay, so humidity is not talking about the temperature, it's not talking about how hot it is, it's talking about the amount of water vapor in the air. But actually humidity will affect how hot you feel. Okay, we'll discuss this later. Okay, so is Singapore humid? Okay, Singapore is actually a very humid country. Okay, reason because when we sweat, our sweat don't evaporate quickly, because the more humid a place is harder for water to evaporate. Why is that so? Again, on the next slide we'll talk about it. And then why is Singapore so humid? Two main reasons. Firstly, we are surrounded by water. Okay, so there's a lot of water around us. That means there's a lot of water evaporating into our country. So since there's a lot of water vapor in our surrounding, that's why Singapore is very humid. Second reason is because we have a lot of plants. We are a garden city. Everywhere you go in Singapore, definitely you'll see trees and plants and grass. So all these plants, right, they release water vapor from their leaves, okay, from their stomata found in the leaf. So because of the plants, because of our surrounding, Singapore has a lot of water vapor in our surrounding. Okay, that's why we are a very humid country. Okay, so you realize that sometimes you go to other countries that's hot, but you don't feel as uncomfortable. That's because although the other country may be very hot, but they are not as humid, so your sweat will evaporate faster, and then you won't feel that uncomfortable. Okay, so how does humidity affect evaporation? Okay, when the humidity is high, you have more water vapor in the surrounding, right? So when there's more water vapor in the surrounding, there's lesser space for new water to be evaporated from water. This will cause the evaporation to be slower lah. So in summary, high humidity is slower evaporation, and low humidity will allow faster evaporation. Okay, I think you're still not very clear, so let's use a diagram to explain. So this is a water that is placed in a place that is highly humid. That means there's a lot of water vapor around it. So now the water wants to release water vapor into the surrounding, but it is very difficult for them because there's not much space. Okay, as compared to the other one, where it's placed in the place or room that is low humidity, that means there's a lot of space. Okay, so the water can easily evaporate out to become water vapor because they can easily find space. If you are still not very clear on how humidity affects the rate of evaporation, just think about public transport. I think definitely everyone has taken public transport before. So a place that's highly humid, you can think of it as a place that's very crowded. Okay, let's say the bus is very packed, very crowded. You want to board the bus, you realize it's very difficult, right? Okay, as compared to a bus or a train that is very empty. Okay, it's very easy for you to board because there's ample of space. Okay, so that's what humidity meant and how it affects the rate of evaporation. Okay, now we'll talk about wind. Okay, wind is basically moving air. Okay, so what happens is when there's wind, the wind will blow the water vapor away. Okay, so let's say for example you are at a place that is highly humid. That means there's a lot of water vapor. So when there's a lot of water vapor, the evaporation will be slower, right? Because there's not much space for water to evaporate. But when the wind comes, you blow away the water vapor. When it blows away the water vapor, the surrounding will have less water vapor, which means it decreases the humidity, and that means it becomes less humid. When the humidity decreases, it means there's lesser water vapor, and that also means there's a lot of space left. So when there's more space, it's easier for your water to evaporate into water vapor. That's why the evaporation is faster. Okay, so to put it simply, when the wind is strong, the evaporation is faster. When there's lesser wind, the evaporation will be slower. Okay, so I mean the best scenario to sun your clothing is on a sunny and windy day. Okay, because on a windy day it decreases the humidity, which increases the rate of evaporation. On a sunny day, there's more heat. Okay, the water in your clothes can gain heat quickly, and the water in your clothes will evaporate quickly. Therefore, overall, your clothes can dry faster. Okay, so I mean there's a lot of information, although there's just 4 factors. Okay, there's a simple way to remember. Basically everything is as per normal. Okay, when the temperature is high, evaporation is faster. When the humidity is more, the evaporation is faster. When the wind is more, the evaporation is only faster. Everything is higher, faster. Only humidity is the special one. Okay, so when the humidity is high, evaporation is slower. Okay, so everything is faster when it is higher, but only humidity is slower. So that's a simple way to memorize it. Okay, now I still have some additional information to share with all. Okay, this slide will be quite important. Okay, now so this one comes out quite often during exam already. So during exam they'll show you 2 setup. Okay, they'll say after I left a pail of water there or a container of water there, after some time I realized I found some water droplets. Okay, one is on the outside for P, and then for setup Q, the water droplets is found inside. What does it tell you about the surrounding? Okay, very simple. If there are water droplets outside, that means the water vapor on the outside just now has condensed. If you remember what's the requirement for condensation to take place, you must lose heat. That means the water vapor lose heat. That means the water vapor is warmer. The water is colder. The temperature of the water is colder than the surrounding. So that's why the water droplets or the water vapor on the outside, when it comes into contact with the cooler surface here, they lose heat and they turn into water droplets. Okay, A typical example is you take ice water, a cup of ice water, you realize the ice water on the outside with a lot of water droplets. Okay, take note, the water from the inside of a cup did not come out. It is the water vapor from the surrounding that condenses onto your cold cup. Okay, then let's look at setup Q. Setup Q, right, you realize there's no water droplets on the outside, whereas there's only water droplets on the inside. Okay, this is a very simple classic example. You understand this better when we talk about water cycles on the next video. So basically what happens is this is a warm water. Okay, or it doesn't actually have to be warm water lah. Okay, because water evaporates at any temperature. But if the water is warmer, the evaporation is faster. So anyway, regardless it's warm or not, the water will still evaporate. And then the surrounding is cooler. Okay, then after some time, when the water comes into contact with the cooler surface here, the water vapor loses heat, right, and then it condenses again. That's how it forms water droplets. Again, a classic example is if you bring your water bottle to the library or any place that's cold. Okay, you realize that when you're about to drink a water bottle, after maybe about 30 minutes, you look at the water bottle, right, the surface will have all these water droplets on the inside one. Okay, it looks a bit like mist lah. Then another favorite question, okay, it doesn't come out that often, but it does come out, and then when it comes out, a lot of students will lose marks. Okay, they'll ask you if the weight of this setup, did it change or not? Okay, the answer is, okay, let me just erase this first. The answer is yes for this and no for this. Okay, if you have guessed, you know why, that's very good. That means your understanding is quite clear. But if you don't, never mind, I'll explain to you. Now, where did all these water droplets come from? It comes from the water vapor inside, and the water vapor comes from the water. So the total amount of water stays the same. You still have the same amount of water. Therefore, the mass in setup Q did not change. What about the water droplets for setup Q? Where did it come from? It did not belong to the container at first. It is from outside. So these water droplets that has condensed onto the surface of your container, they come from the surrounding. It does not belong to the container at first. So basically it means your container now has more water. Since it has more water, that means you have more mass, because water is a matter, and matter has mass and occupies space. Properties of matters, so remember that. Okay, this is not very important, but I just want to share with you. Okay, I know that we often say that heat expand and cold contract. If you watch the heat video, you still remember this. Okay, but I also told you in the heat video that during freezing, right, during freezing, right, water actually expand. That means they take up more space. Although they are losing heat, by right they should contract. Okay, but actually they expand because water is very special. And then when they melt and they are gaining heat, by right when you gain heat you should expand, right? But no, they contract. So that's why if you look at the cup on the right side, right? Okay, you realize there's an extra portion here, right? Okay, after this thing, the ice melt, the water level will stay the same. Why? Because like I say, when they melt, they contract. Contract meaning they take up less space. So that's why the water level will not increase. Okay. For expansion wise for water, you just draw a quick illustration. Okay, I don't know if you have heard about this instruction from parents. You are advised not to put glass in the freezer, because if you have glass with water in the freezer, what happens is when water inside freezes, right, they will expand. That means when they expand, they take up more space and you push the glass outwards. Then the glass will crack. But actually, that's not the main reason why that's not the only reason why glass crack. Another reason why glass crack is also because of uneven expansion. Okay, maybe I'll just explain quickly. Glass is actually very thick. Okay, uneven contraction and uneven expansion. So when we put it in freezer, the outside will contract faster because the outside is facing the freezer directly. This one will contract also, but slower contraction. Therefore, outside become shorter faster, inside become shorter slower. So outside will become shorter, outside will become longer. So it will crack again. Okay, but this part is actually not related to water lah. I just want to share, okay, the two reasons why when you put glass inside the freezer it will crack. Okay, so just don't put glass inside the freezer lah. Okay, that's all. Thank you for watching. If you can, share the video with your friends. There will be one more video on water.